Welcome to This Explainer. Today, we're diving into a completely radical framework by Dr. Ahmad Rihan that redefines something we literally feel every single day: heat. But we're looking at it as a microscopic magnetic phenomenon. It's a real game changer.
To understand how the shape of a planet connects to something like an induction stove, we're going to zoom all the way down to the atomic level and back out again. We'll quickly cover the mystery of heat, the atomic jump hypothesis, Lenz's law, the pyramidal atom model, why nature loves spheres, and then wrap it all up with a unified physics framework. Let's get into it.
Part 1. The mystery of heat. We're rethinking thermal energy right at the macroscopic level. So let's start with something super familiar, an induction cooker. You know that when you turn on that stove, magnetic fields are doing the heavy lifting to safely cook your food, right? Well, this brings us to Dr. Rihan's central, brilliant question. It really challenges the whole foundation of thermodynamics. What if all heat is actually just transverse magnetism?
Now, this is the massive paradigm shift we're unpacking today. On one hand, you've got the traditional textbook view, right? That heat is just the random, chaotic, kinetic jiggling and bouncing of atoms and molecules. But then you look at Rihan's hypothesis. He's proposing that heat is actually the macroscopic manifestation of transverse magnetic swirls, all generated by structured, alternating atomic jumps. So we're taking this chaotic, random motion and replacing it with highly structured, perpendicular magnetic perturbations. Absolutely wild.
Moving on to part 2, the atomic jump hypothesis. Let's zoom right into the microscopic engine.
Okay, to see how every single atom acts like a tiny little induction cooker, we need to map out the microscopic mechanics. The really crucial point here is this exact sequence of events, where longitudinal energy input transforms into orthogonal, or perpendicular, magnetic swirls. It goes like this. First, energy is absorbed. Second, the atom jumps or oscillates. Third, that motion creates an alternating microscopic current. Fourth, thanks to the Ampere-Maxwell law, a transverse magnetic field is generated. And finally, step 5, that energy dissipates transversely. And that's exactly what we feel and measure as heat.
And you know, we can actually see this mechanism acting universally all around us. Think about solar heating. Incoming electromagnetic waves from the sun excite the Earth's atoms, producing these exact transverse magnetic swirls. Or take a spark plug. High-voltage plasma energizes the atoms, inducing jumps that preheat the fuel mixture via transverse effects. Even just lighting a simple match triggers these molecular jumps, sustaining a cascade of magnetic thermal spreading that we literally see as a flame. It's kind of mind-blowing when you realize that the massive sun warming our planet and a tiny spark from a lighter are using the exact same magnetic thermal mechanism.
All right, part 3, Lenz's law and feedback. This is all about the self-regulating thermomagnetic loop.
Now, you might be wondering, if all this atomic jumping is creating heat, why doesn't it just instantly spiral out of control and melt everything in a thermal runaway? Well, to answer that, we have to look at a fundamental rule of electromagnetism, Lenz's law. It states that the direction of an induced current is such that the magnetic field it produces opposes the change in magnetic flux. So in the context of our atomic jumps, Lenz's law provides this built-in, self-regulating opposition. It completely prevents runaway thermal effects and gently forces the energy to thermalize.
What's super interesting here is how perfectly the macroscopic engineering of an induction stove maps directly to the microscopic behavior of atomic lattice ions. At the macro level, high-frequency alternating currents generate changing magnetic fields, right? And those induce swirling eddy currents. Thanks to Lenz's opposition, these currents create secondary fields that oppose the change, spreading energy transversely and causing Joule heating. Well, under Dr. Rihan's hypothesis, the microscopic parallel is completely identical. Atomic jumps are undergoing this exact same process, just down at the quantum scale.
And it gets better, because this system feeds on itself in a really controlled way through what's called the Arrhenius feedback loop. Basically, as things heat up, those higher temperatures exponentially increase the speed and frequency of the atomic jumps. That rapid increase amplifies the alternating currents, which in turn intensifies the transverse magnetic heat generation. It creates this absolutely beautiful self-reinforcing rhythmic cycle between thermodynamics and electrodynamics.
Part 4, the pyramidal atom model. Let's look at the specific geometry of an atomic jump.
So what exactly is the structural engine making all this possible? Let's check out the Rihan atomic model, or RAM for short. This is a framework where the atom's core actually features a central pyramidal body. And this unique shape executes periodic, vertical, bidirectional helical jumps. This produces intrinsic chirality and vorticity, which, honestly, is just a fancy scientific way of saying it has a built-in twisting spin.
So instead of just randomly bouncing around like a rubber ball, the atom has this highly directional twisting geometry that mathematically forces energy into a very specific, structured path. Let's actually trace that path. Step 1 is the upward jump. The pyramidal body spirals upward while revolving to the left, or counterclockwise. Then, step 2 is the downward jump. It spirals back down with a reverse revolution, creating a clockwise return path. Because of this really specific twisting geometry, the energy literally can't just bounce randomly. It is mathematically forced to create time-varying displacement currents, and that is exactly what generates those magnetic swirls.
Moving to part 5, why nature loves spheres. This is the macroscopic consequence of transverse heat.
Okay, let's zoom back out from the tiny atom to the cosmic and biological scales, because the ramifications of this theory are massive. Since heat is forced to spread purely transversely or perpendicularly, nature actually optimizes for this by building spheres. Think about stars and suns. Their spherical shape ensures uniform transverse thermalization at every single radial shell, which maintains hydrostatic balance. On planets, isotherms strictly follow latitudinal parallels, and it even applies to biology. Fruits and seeds optimize their internal volume while ensuring totally uniform heat, moisture distribution, and metabolic activity across their spherical cross-section. Seriously, the next time you're in the grocery store looking at a perfectly round peach, realize you are looking at a masterpiece of magnetic optimization.
It brilliantly illustrates that a planet, or an apple for that matter, isn't just round because of gravity or basic volume dynamics. No, a sphere is literally the optimal geometric configuration for dissipating magnetic heat. Radial energy spreads perfectly sideways in all directions, creating completely uniform horizontal temperature rings. On the flip side, non-spherical shapes induce really inefficient lateral heat flows. That leads to localized hot and cold spots and severe thermal stresses.
And finally, part 6, a unified physics framework. We're connecting the disparate dots of nature.
So stepping back, we can really see how Dr. Rehan's hypothesis elegantly ties together concepts that up until now seemed completely separate in the textbooks. By framing heat as a magnetic eddy current born from these atomic pyramidal spirals, we get this beautifully unified electrodynamic thermodynamic framework. I mean, look at what it does. It unifies thermodynamics with Maxwell's electrodynamics. It explains the complex engineering behind Peltier's cells and thermal electricity. It gives a totally new context to Faraday's inductive magnetic limbs. It even connects solar heating and chemical combustion under one single transverse paradigm. And as we just saw, it mathematically explains why biological and celestial entities favor that optimal spherical shape.
I'm going to leave you with this provocative thought to ponder today. If biology and astrophysics are already out there optimizing for transverse magnetic heat using spheres and chiral geometries, what kind of futuristic, bio-inspired thermal technologies could we build by engineering our own artificial magnetic limbs? The possibilities for things like advanced cooling systems, thermoelectric generators, or even new energy harvesters are absolutely staggering. Thank you so much for joining me for this explainer. Keep asking those big questions, and I'll catch you next time.